Hello and welcome back to the Oxford MAT Livestream. My name's James and we're going to be talking about graphs and transformations today. That's part of the Maths Admissions Test syllabus. But first, a quick shout out to people watching in chat. Who can I see who's here today? Hi Raphael, hi to Noah, and I saw Amy as well, and Shizzy. Hi to Nicholas, hi to other people. There's loads of anonymous people checking in as well. Always great to have you with us too, including someone here who says that they're coming to Teddy Hall. Hooray! After winning the Big Think competition. Goodness, I don't know anything about the Big Think competition, but hey, if you're around the maths department, say hi. I think I mean that literally. Yeah, cool, right. Hi to other people joining as well, Revel and some anonymous people, and Tom and Tia. Brilliant. I love it when people jump into the Slido to say hello at the start. It reminds me that there are actual people out there, even anonymous people, jumping on, so you get an anonymous shout out. And even brands of calculator are here as well to find out about some graphs. This is a slightly sort of mixed feelings kind of live stream today, because graphs has got two meanings. At A level, graphs means drawing pictures of functions. And then later in life, in your mathematical career, you find out about this other meaning of graphs, where they mean about things being connected together and things being joined up, and looking at how the connections work and doing fun stuff with those. And it turns out to be that sort of graph is really exciting and is nothing to do with what shapes things are. But the sort of graph that we're doing today is all about what shapes things are. And it was Denim coming to Teddy Hall. You should definitely come and say hi, because you'll be not that far from the maths department. I'm not at the Big Think event, but you should come over to the maths department. That goes for everyone, by the way. If you're in Oxford, what am I doing? these get views. If you're in Oxford and you're and it's during work hours, what's work hours? Doesn't hurt to come over to the maths department. Very least, if I'm not around, you still get to see the maths department. Good, right, good, okay. Decisions. Right, D1 maths. Do people still call it D1? That warms my heart, that people still have the concept of something called D1, because that's a very modular sort of thing to call A levels. And I'm old. Back when I did things like this, it was all modules, and you would do things like C1 and D1. I think I've previously gone off on a little bit of a rant about, not a rant, but remembered C1. Yeah, D1 has these people having strong emotions. Right, okay. Because unfortunately they get you to do some cool stuff, but they don't get you to sort of prove that it works. So I don't know. Maybe they've changed how it all works since it stops being modular. Right, I should stop going on about A-level mathematics, which is not something I'm, it turns out, keeping up with entirely. Yeah, you should come and see our Penrose styles if you're in the maths department for any reason. We've got an open day coming up. I should probably advertise that. If you're looking for an excuse to come to the maths department in Oxford, there's a great big Oxford open day on the 16th of September 2022. We're doing a few maths talks, not very many, but it's also a chance to see some of the colleges in Oxford, to have a look around and see those. Other stuff like, come and have a look at the Penrose tiles if you want to. Right, cool, how are we doing? We've got some people watching, we've got some maths happening. Well, no maths is happening yet, but we've got people talking about maths at least, which is half the challenge. I'm going to be there, I'm doing a talk about admissions for maths. If you've watched this live stream, you've already heard all of the jokes at least. Choosing college, I'd recommend. Oh, sorry, there's lag, isn't there, before the... There we go. Choosing a college, asks Eleanor. Visiting colleges is a great way to do it, or just visiting their websites and have a look at the different bits and pieces. Kai asks if we've moved the bin that used to be near the hand in work here sign. I think it's still there. There's a sign that says hand in work, and there's a bin right next to it, which Kai pointed out to me once is quite funny. I don't think we've done anything about that yet. It's just going to be one of those funny things. You can do the open day, and the open day is open. Do whatever you, the building's open. You can come and look at the building if nothing else. Right, cool, let's talk about graphs. Let's draw some graphs. No, let's do the poll for how's your day. Let's do both at the same time. How was your day today, chat? How are you doing? You alright? How's it going? I'm having, I think, a 4-star day, which is one of my better days. And I'm hoping it'll be 5-star after we draw some graphs together. I am using my graphics tablet for this one, so we'll see how my ability to draw graphs using this using this graphics tablet thing. I've definitely moaned about the graphics tablet before. It is the cheapest graphics tablet I can find. That's going to be the kind of standard we're going for today. That is my picture of sine x. Cool. Maybe if you're playing along at home, you can maybe draw better graphs than that. Often when I'm drawing graphs, I just do a sort of sketch to try and remember the basic shape of things that are going on like that. It's my picture of sine. Hopefully we can also do cosine and maybe also tan. Tan's quite exciting. It's got these points where it goes very, very vertical. Yeah, more like a fine curve, am I right? Says somebody in chat. And people's days are going quite well today. I think going at home. I guess it's August, so it's the holidays, right? It is still August, right? Yeah. Okay. It's still. So I guess people are doing slightly better for the holidays. Sometimes I do these polls during the middle of term, and everyone's like, "I've had enough of this." Good. Right. And an anonymous person has asked which college I teach in. I currently do tutorials for New College, currently. And if you're not at New College in the following year, then it's unlikely but not impossible that I will teach you. Cool, right, we'll see. I'm always trying to take on one teaching. Right, teaching's fun. Can I mention OOMC in my personal statement? Ask somebody in chat, and the answer is yes, you can. Your personal statement, well, there are also very, very few rules on that. You can mention whatever you like in your personal statement. Mentioning that you've been thinking about extra bits of maths by watching some videos with extra maths in as inspirations for thinking about topics from maths. Part of the idea of that maths club was that you would see your favourite bit of maths there, discover a new favourite bit of maths, and use that as inspiration for something to find out more about. Log's a really good graph. I really like log. I probably talk about log too much. I probably set too many math questions involving log, not all of which get approved. Log's great. It grows really quickly over here and really slowly over here. So really quickly near zero. It gets really flat over here. On the MAT syllabus, you're not expected to know the derivative of log, so you don't actually have a way to interact with how steep it is over here and how flat it is over here. That's not something we can ask you about on the MAT, but you are expected to be able to draw the picture, I guess from memory, of what the logarithm function looks like. 5 stars. Somebody in chat said that their day was like a complex number out of 5, which it's complicated. Will unis hate you for talking about unique and OOMC? Why would they hate you for joining in with Oxford stuff? We're lovely. We do maths things on the internet. Oh, right. Okay. Carl Frederick Grass has explained. Anonymous person, you're correct. Here it comes. Chat lag. The derivative is 1 over x, but we don't know that for the math syllabus. We don't know how to differentiate log. That's the derivative of the natural logarithm. If you didn't know that fact already, then sorry for the spoilers. You will learn that for real at some point. But the derivative of the natural logarithm, the one with base e, is very secret. It's 1 over x. Yeah, I hope Gauss is okay as well. Yeah, good. Right, try not to mention complex numbers challenge. Impossible. If you run out of space for a long question on the MAT, it's really annoying because I keep starting to answer the question before it appears on the screen. That's irritating, right? If you run out of space for a long question on the MAT, you can answer using other blank pages in the booklet, in particular ones at the back, or for questions that you're not doing, other pages in the booklet. That instruction is also written on the front of the test if it comes to it. Okay, so for the MAT, what do we expect you to know? It's not how to differentiate logarithm. We expect you to be able to draw the logarithm function. Also things like square root of x, a to the power of x. Maybe have a go at other powers of x, I suppose. There's a different section on polynomials somewhere, so definitely you should be able to do like x cubed, x squared, and things like that. So you might be able to do something like that. You might be able to, so square root of x, remember that's x to the 1/2. Other powers of x, I reckon you should be able to do as well. There's a long MAT question from the past about the differences between x to the 1/2 and x to the 1/3. So getting involved in those as well. You should be able to work out what those pictures look like, I think. Good. Okay. So we've also got transformations. That's the other half of what we're talking about today. Transformations of graphs. I've got the 4 most common ones on screen here, ones that you're expected to know. You're expected to know what effect these have on the graphs. 2 of them are kind of easy to think about. This one, takes all the values of your function f of x, so it takes your graph of y equals f of x, and multiplies them all by a. So values, I guess, this is more of a way to remember than what you would actually write, but values get a times bigger. There we go. We've been multiplied by a. Okay. So multiplying it by a, and this one over here, this is some sort of stretch parallel to the y-axis. Over here we add a, so it goes up. If a is positive, I guess. I'm putting these in quote marks because these are kind of not very precisely worded things. You might talk about a translation parallel to the y-axis. There's a question in there. At Oxford Uni, when you practice past papers, you're not given solutions. That's not true. For the maths degree, they're given lots of past papers, and they're given official work solutions for some of them. Not for all of them, because we want them to save some to find out the solutions by talking to their tutors, but we give them some. Right, cool. Yeah, we're going to talk about ax squared plus bx plus c and what those numbers all mean. Good, right, cool. Okay. Graph of, relationship between these and the graph of y equals f of x. Okay, good. Whoa, yeah, okay. We good? I suppose there should maybe be e to the x on here. I suppose it's included in this case of a to the x, anything to the x. Let's quickly do e to the x as well. E to the x is a very nice function that goes flat and then very steep. I should really slightly curve that down at the end there. I should be curving upwards. Cool, not my best picture. E to the x semi-famously goes through number 1 over here. And I suppose a to the x does as well, because a to the 0 is 1. Powers coming up another time. Okay. Good. MAT is relative to everyone else. It's usually about 70 is pretty good, but it is relative to everyone else. Okay. So revision to check what that stuff on the syllabus means. The graph just means the points that satisfy the equation. Usually when they're written like y equals f of x, that just means like essentially evaluating the function f of x at lots of different points of x and finding out what the values of y are. That's called an explicit function, not because it's like 18 plus, but because it's a function where y is on its own on the left, and it's really kind of obvious what you do. You put x in and you get values of y out. Sometimes you see ones where it's less clear what the relationship is. So the equation might be something like x squared plus y squared equals 1, where you can still talk about the graph of that equation as being all the points that satisfy that equation. Now there's lots of points that satisfy this equation. They all lie on a circle. That's the equation for a circle. So you can still talk about this being the graph of the equation, even though there isn't a function f of x where you can write y equals f of x for this graph. So you need to be able to sketch graphs like this, but also be able to sketch the points that satisfy an equation, and that might be referred to as a graph as well. Right, okay, yeah, so Kai says y is explicit function, y equals and not x equals. I suppose maybe I would refer to x equals. I think I might refer to that as an explicit function as well. Yeah, I'm happy with that, I think. But then what are x and y? Good, right, okay. We got a big fan of step in chat, that's fine. And we got a question about personal statements in capitals. You talk about whatever you like in your personal statement. I'm going to ignore the personal statement question, partly because it was a bit shouty, but really focus on this ax plus b transformation question. We'll come back to these quadratics in a second. I think this is really good. James, they ask, for y equals f of ax plus b, do you have to factor out a first? So it's a personal question. They're asking me whether I have to factor out a first, maybe. And the answer is yes, I personally do have to factor out the a first. I don't have a way to remember what that looks like. So for me, I would have to do that in 2 steps. I quite like opinions from chat. If you were faced with something like this, where a and b are numbers, this is sort of 2 transformations that have happened. Do you have a mnemonic for remembering this? Do you have a strategy for working out what this compound transformation means? what is this? What's happened? What's going on? Okay. Predicted grades are quite important. We will look at your predicted grades, but also, yeah, just do it. It says Carl, let's do AX and then plus B. Does that work? I think that's. I've got a feeling that might be the wrong way around, but you know, we can always get it the wrong way around and then get it the right way around and fix it. And then we got a follow-up question I want to do as well. F of AX minus F of A minus X. I want to understand that one as well, because I think that's also a sort of compound one. So it feels very, there's a trap here, I suppose, where, yeah, okay. There's a trap here where it looks like if you were calculating the numbers, you would multiply by A first and then add on the B. But you need to think about this in terms of, well, you don't have to think about it in any particular way at all, I suppose. But if I start from y equals f of x, then when I do a transformation, I'm sort of replacing the x with something else. So for me, I would do the translation first. That means replace the x with x plus b. And then I would replace the x with an ax. Let me put some arrows in to sort of show what I mean. It's replacing the x with an x plus b, and then replacing the x, the input variable, with an ax. The transformation applies to the variable x rather than to the input of the function, which is maybe a bit more complicated than it needs to be. But yeah, okay. So thinking about it in kind of reverse. So I think it's a translation and then a stretch. I think. Can we test this out with numbers like, we test that out like 1 and 1? No, 1's rubbish. 1's really boring because stretching by a factor of 1 doesn't do anything. Maybe try this out at home. I think I'll leave this as homework or exercise for the reader. Try picking your favourite function f of x and then drawing f of 2x plus 1 and try to understand whether it's a translation followed by a stretch or a stretch followed by a translation. It's one of the cards on the MAT flashcards, which is a resource that we've made that's linked to in the YouTube description. One of the MAT flashcards has this on. I got some feedback from some students, and one of the students said you need to do a card that says f of ax plus b. And we thought about it really, really carefully for the card. So if you want to know, then check the card. Yeah, focusing on x each time. Yeah, okay. Yeah, I think I agree with Rabil. Okay. Yeah, so you can do a stretch. Okay, here's a great suggestion. You can just add b over a and then stretch the whole thing by 1 over a. I think that's true. So there's this kind of other two-stepper where you go. let's make this picture more complicated. You go via. This involves a little bit of planning ahead, right? X plus b over a. So that's a different sort of translation. It's a translation by minus b over a to the left. To replace that x with x. B over a. What am I doing? Oh no, they're not trying to do that. They're trying to do the scale first. What am I talking about? I've confused myself. Oh yeah, this is it. You can scale first. But then your translation that you do afterwards needs to be by b over a, not by b. So people who are suggesting pulling out the factor of a, I think are talking about pulling out the factor to make it a times x plus b over a. So it's like f of a of x plus b over a. It's still a little bit confusing, isn't it? Right, good. The card says translation then stretch by minus, yeah, so translation then stretch. There's this alternative where you stretch first but then you translate by a complicated amount. Warning, not quite the amount that you're expecting. The flashcards are on the MAT website. If you search for Oxford MAT Test, you should be able to find the flashcards. There's also a link in the YouTube description or on the MAT Live homepage. Link on the screen. I know you can't click the link on the screen. Good, right, super confusing. Person who was talking about why different compound thing over here, they were asking about why, oh my goodness, all the letters wrong at once. Yeah, one of those live streams, isn't it? Which I think is f of minus x minus a. And that gives me a clue about how I'm going to make it. I think I'm going to reflect first and then translate. Yeah, I think I'm going to reflect first and then translate. Right, good. Okay. And Kai. Thank you, Kai. Here it comes. Kai is linked to the flashcards in chat. That is the sort of chat behaviour that makes this chat just best chat of any live stream in the world. Why aren't reflections detailed on the revision page? Well, I did tell the story that they should maybe be on the revision page. Didn't put them on the revision page. Maybe they should be here. We should do some more reflections. Good. Good. James is going to keep adding links to the bar at the bottom of the screen, so you can't even see any of the questions. Just links. It's all up. You join the live stream. Just 2 hours of me babbling away with a bunch of resources linked on this side. Good idea, Jack. Join us next week for so many links. All of the links. We can all imagine what the links are. The links are like, here's the step support program. Here's the MAT syllabus. Here's the past papers. Just work it out. We made some flashcards, add that to the bottom. Good, right, no, we are going to do a proper live stream, let's do it. I'm thinking about how much of the revision stuff I want to talk about. I reckon you either already know this or you don't know this. If you don't know what these graphs look like, then thanks for joining us today. Please download this PDF or go to the website version and have a look at some graphs, and you will learn what pictures of functions look like. Or very quickly zoom in, pause the video and zoom in now for some graphs. And we've got some definitions and stretches. Good, right. Should we do some warm-up? Should I do a poll? I forgot what the poll was for. Cool, good. There is one vote in chat for, and this would be such a time sink. You should really make an equivalent for the step support program for the MAT. Right, good, yeah, timesheet. Right, worksheet has a long question. Should we do the long question first? We should do the warm-up. We'll do a little bit of warm-up, and then we'll do a little bit of warm-up to talk about quadratics, because I saw someone asking. Then we'll do the long question, then we'll do some short questions. What a mad sort of series of things. Yes, Chris, I'm going to do A, B, and C. We're going to talk about it. So I gave you this kind of quite hard warm-up question, which if you're getting the sheets ahead of time by going to the website, link on the screen, then you have been given quite a lot of work to do. Sorry about that. I'm going to do some of it on the stream, but not all of it. The thing I'm trying to explore by getting you to look at all of these different cases, and I went through all 8 of them, is what A and B and C actually mean in the quadratic. I've got a kind of algebra approach to try and explain what's going on. Let me walk you through it. Here's how it works. So the A out of the front here, that tells you what's going on very, very far away for a very large x. So essentially, when x is very large, x squared is much, much bigger than x, and it's definitely bigger than whatever this number is. If it's not bigger, then just make x bigger until it is. So if a is positive, then it's sort of a quadratic that eventually goes upwards out there. And if a is negative, there's a quadratic that's eventually going down. Sometimes people call these a happy quadratic and an unhappy quadratic. Happy quadratic, sad quadratic, for those two cases. So there's a bit of that going on. I think you know what the number c means as well. So the number c means at x equals 0, that's the y-intercept. So if c is positive, let's do some different cases. My picture is going to be sort of all of the different cases all at once because, I'm sorry. If c is positive or if c is negative, then it's where the y-intercept is. Where does the graph go across the x-axis? In a way, I suppose, this is like saying when x is really, really small, when it's really close to 0, it's this term at the end that matters. When x is big, it's the x squared term that matters. It's like ax squared. And when x is really small, it's these small things and x squared tiny, so it's the c at the end that matters. Good. And that just leaves b for us to understand. So b says something about what's going on in between. So I have 2 interpretations for b. One of them is that b tells you something about the gradient at x equals 0. Let's work that out really quickly. If that's the quadratic, then the derivative is 2ax plus b, which at x equals 0, that's b. So if b is positive, then I guess in these little sketches I just doodled over here, b was kind of 0 in both of those because I drew the minimum of the quadratic over there. Not great. If b is negative, then it's coming down as it crosses the x-axis. And if b is positive, then it's going up. So taking into account both of these pictures, we've got c positive. This is why I gave you 8 different cases to think about, all the different combinations of these things. So that's one interpretation of what b means. It's something to do with the gradient when x is 0. But there's something else you can say, which is that you kind of know where the turning point of the quadratic is, if you want to think about it like that instead. So the turning point is where the turning point is at 2ax plus b equals 0, which is at minus b over 2a. So if a and b have the same sign, which is 4 of these cases, then that's negative. And if a and b have different signs, then this is a positive number. Which is actually consistent with all the other things. You if you put it together, then if b is positive and your quadratic is eventually going down, you're in the case a negative, b positive, then you've sort of got to have a turning point over here. You can sort of infer that from the gradient over here and the way it goes down eventually. What goes up will come down. There's a turning point in between. And you can think about the other cases in a similar way. But these are different ways that you might bring some algebra into it to think about the different cases. I haven't said anything about roots. Quadratics are great because you have a method for actually solving them. So you might like to think about how minus b over 2a is the average of the two roots. You know that because you know the quadratic formula. It's got this minus b out the front, right? Minus b plus or minus some stuff over 2a. So minus b over 2a is the turning point. Minus b over 2a is the average of the roots. It's also the position of the turning point. So putting those together is good. I'm really hoping Nicholas has linked to a Desmos thing that I think they might have made, which I'm really hoping, is it a quadratic with sliders? It's a quadratic with sliders. Yes. Thank you, Nicholas. Look at this. Thank you for this. Playing around with different values of b and c. It's worth playing around with things like this because this tool didn't exist when I was in school, and now it's a thing. So you play around, look, b being negative and b being positive, you flip it over and it goes the other way around. Think about it being the average of the roots, which kind of makes sense because quadratics are nice and symmetric like that. Excellent work, I love it. Right, good. Yeah, so something about it's really it's really b over a that's important. Just b on its own is sort of a little bit misleading. You've got to worry about a as well. If you're interested in where the turning point is and where the average of the roots are, then it's b over a that's really interesting. I like the combination of the signs of those two things. Cool. Right. Good. Yes. Has this chat stopped? No, chat's still going. Good. Okay. So 8 cases. My sketches there are terrible. You can do better than that. Sometimes the live stream, we try and do things so badly that you're irritated, and irritated and you want to go and do them better yourself. It's a form of engagement. Annoying you into doing it better yourself, which you're welcome to do. So there's some translation practice and some multiplying stuff around. These are not the same because order matters for this sort of thing. It just turns out that they're different functions algebraically, and moving things around as well, doing compound translations. Practice that if you want to. We've got some logarithms going on. Do I care about this question? Let's do some logarithms. So if you just met this for the first time just now, hey, here's another picture of a logarithm function. This point here is 1 because of how logarithms work. I don't really feel like putting any more points on this. And this log base 2 of x squared is the same thing as 2 times log base 2 of x. So I just need to double my previous double it up. 2 to the x and 1/3 to the x. 1/3 to the x gets smaller the bigger the x gets because you're putting in kind of more factors of 1/3. 2 to the x gets bigger. 9 is a sort of weird question I threw in. And 10 has got some other stuff going on. Yeah, great question in chat. Not about Formula 1, sorry, it's not a Formula 1 stream. A, B and C relate to in cubics. Great question. And also you could ask about D as well, because cubics have got an extra parameter. Really for fun, I think. Make yourself a cubic slider in Desmos. Just type in a general cubic and click yes to all the sliders and mess around with them. It's really good fun. Lucy knows that some of the past papers do have solutions. I'm really glad that Lucy's doing well on TikTok. Good. I'm not trying to cause TikTok drama. Lucy does get solutions for some of the past papers at Oxford. Good. Did I miss the negative curve for log of x squared? No. Oh, did I? Oh, yeah. Good point. You've out-mathed me for my own question. When x is negative, there's a bit like this, isn't there? Because when x is negative, it squares up to a positive thing. Huh. You've out-mathed me at my own question. Yeah, should probably change that in the solutions. Whoops. Good. Oblique asymptotes are not on the MAT syllabus. You're not expected to know about them for this test. A, B, C, and D. So you can label vertical asymptotes, I suppose, if you want to. There's one over here. It's usually obvious from people's pictures where they put the vertical asymptotes. Raphael has made the cubic slider thing, I hope. One of these days somebody's going to embed a Rickroll into a Desmos chart and then put that together. Yeah, so this negative bit over here, when x is negative, this is awkward now because it's not equal to 2 log base 2 of x for complex number reasons. I regret this question. So I wrote this question because I thought it'd be fun, because I thought this was secretly equal to 2 log base 2 of x, which it is if x is positive. It's actually equal to 2 log of mod of x. But I think that's a bit mean, because you probably wouldn't think of that. In fact, I didn't think of that when I wrote this warm-up question. Now I'm getting distracted by it. Maths is lovely. One of the things I really like about maths, I'm going to cover for my mistake now by going off on a tangent about mathematics. One of the things I really like about maths is the way that you can ask a simple question and then it turns out to be an interesting question, even if you didn't really mean it to. There's actually something going on there that makes it harder than I thought it was going to be. That you think you're playing in kind of the shallow end of the swimming pool, and then it turns out, no, that was the deep end of the swimming pool and there's something going on over there. And for this particular live stream, it's not helpful for me to go and play in the deep end of the live stream. But all I'm going to say here is that when x is negative, x squared is positive, and it should in fact do the same thing as when x is positive. If I put in 3, I should get the same thing as when I put in minus 3, because both those will get squared up to 9, and it'll be log base 2 of 9, which is the same thing. If c is bigger than 0, you say it's got no roots. Might have roots. If I've said that, I was wrong. Why not all the past papers? Yeah, some people were worried that if we gave people all the solutions, then that nobody would do any actual revision, which is probably not true, but would be pretty bad. Are there solutions for these worksheets? Jack's got a point, right? Okay, yeah, there are solutions for these worksheets. They are on the MATLive website. So MATLive website, if you click solutions on there, which is quite hard to find on mobile. I think if you're on mobile, you've got to scroll all the way down. Sorry. To find the button to click for solutions, but there's a separate web page out there buried underneath on the website for solutions as well, as also PDF on the main MATLive page if you want PDF. Right, good. Oh my goodness, everyone's submitting Desmoses at the same time, just after I suggested that it would be funny for a Desmos to do a Rickroll. Yep, good, exactly, thanks Alfie. Alfie was first, so Alfie can have that one. Brilliant, I know that you didn't just make that. And everyone's now doing it, good. Good, okay, what are we doing? We are doing some transformations of graphs. It's about 5:30. I think we're going to finish by talking about question 10 on the warm-up. And then we're going to skip over and do a hard math question, which would be good, because we usually do the easier ones first. So we're going to do the hard ones first. Good, right. Is it true that if you're doing 2 transformations, one affecting y and the other affecting x, and it doesn't matter what order you're doing them in? Right, let's think about it. Let's think about it, chat. That sounds true to me, but I'm willing to be wrong. Okay, so if, for example, your y transformation is translate 3 units up, and your x transformation is stretching or squashing, then yeah, you can squash and then lift it, or you can lift it and then squash it, doesn't matter. Algebraically, f of 3x close brackets plus 1 is the same thing as f of 3x close brackets plus 1. That was useless. Right, good. Okay. Probably makes more sense if you start writing down what happens as a result of doing those 2 transformations, one then the other. Good. FOI shows that CS department, I've never heard about this. Quantum data to use thresholds, but I don't know what quantum data is. Gosh. Doesn't sound like the sort of thing that I'm doing, and I'm in charge of math shortlisting, so I think I would know. Right, good. Okay. Right, we're going to do this question, which has got a kind of secret surprise. So this is two transformations that have happened. We've done the graph of three, maybe, I suppose. Yeah, you could think about this as three transformations. Cos 2x means take cosine and squash it. So out to 360 degrees. Now I'm going to get two. Well, but that's not cosine, James. That's sine. Come on. Two lots of cosine. And now everyone in chat's going to tell me it's sine because of chat delay, which means that you don't get to see me. You don't get to see me at my best fixing things. Yeah, thanks. There we go. Thanks, Raoul. Okay. So that's cosine 2x. And then the question says we want to take half of that and add 1/2 to it. So there's a y squashing it in the parallel to the y-axis, and then adding on 1/2. So if I squash it, it starts being between -1/2 and 1/2. And then I add 1/2, so it's going to be from 0 up to 1, which is going to look like this, I think. Like that. Ah, that's not bad. That's not bad. 0 up to 1. Thinking about the limits there. I knew it was going to be about the same shape, but thinking about the limits was helpful for me doing that graph. Okay, this is here because at some point later on in life, maybe you've already learnt this fact, or maybe it's coming up later for you. At some point you learn that this is equal to something really nice, like cosine squared x, which is a surprising fact. It's not obvious. And there's a reasonably common question on sort of A levels or something to sketch cosine squared of x, cosine x times cosine of x, which sounds really, really hard because everybody learns this fact that it's equal to this, but then forgets that it's equal to that, and also forgets that they know how to sketch that graph. So everyone draws really weird stuff for cosine squared x, even though it's equal to this, which you can sketch like this. So it's sort of one of those things about like joined up knowledge that catches people out. Yeah, Kai, that's the face I'm trying to draw, but I didn't do it very well. Oh, chat lag. There it is. Thank you, Kai. When's the deadline to sign up? Deadline is slightly earlier this year. It's end of September. Please also make a UCAS application if you're. You can take the MAT if you're applying to Oxford or Imperial or Warwick for particular courses. You need to do the UCAS application as well as the MAT test. It's not just a fun test for do this test to stand out. It's a part of our application process. Curve sketching. This one, sorry if you thought about this curve for ages. Well, I kind of hope that you thought about this for ages. This one is something that I wanted you to think about really carefully. That it's like x is like plus or minus 4 minus y squared, which is like quite complicated translation and replacing y with y squared. So what's going on there? But because I'm hilarious, it's actually just the circle x squared plus y squared equals 4. So I hope you thought about it. I hope you did the warm up to think about that. But also rearranging and doing algebraic stuff is like that too. Instructions on how to sign up on the website, and it is usually through your school or wherever else you do exams. Okay, when do you learn about cos squared? I think it's in Maths A level in the second half. So if you're learning Maths and further Maths in parallel, then you find out about that cosine squared fact later on. The fact that you learn is like there's a relationship between cosine 2x and cosine x. And there's also a nice relationship for sine 2x. In fact, I'm going to tell you it now because I can still remember the time that, this is side note, this is not math. I can still remember the time that I went to an after-school maths club and one of the sixth formers showed me this fact. And it was sort of how I knew that I was going to enjoy maths at A level, because it was after school maths club, and one of the sixth formers took the time to just show me that this is true, or they just told me, and I thought, oh, brilliant! I can use this if I want to do. I can do stuff with this. This is brilliant. I can appreciate this link between sine 2x and things that I already know about sine x and cosine x. And see no obvious reason why this should be true to younger me at a maths club after school, but maybe there's somebody watching this who didn't already know this fact, and I've now passed on the mysterious knowledge. Not going to prove it, not going to tell you, but hey, there's a cool fact that's coming up for you. If you like the look of that, then I think you're really going to like Maths A-level or equivalent. Good, right, okay. Or equivalent, I have to keep saying. Got to keep saying or equivalent. Not everybody here is in England. Right, good, okay. You can derive them using imaginary numbers. Chat loves complex numbers. You just love them. every time there's a little sniff of getting some complex numbers in somewhere, I can always rely on chats to point out some complex numbers. Okay. This was, I think, one of the first questions we ever did on the MAT Livestream in about 2020. And it was not very good when the first time round, a couple of years ago. So I've learned, I've grown, I've got better as a streamer, got better as a mathematician, and we're going to have another go at doing this question. Helped this time round by having significantly more people watching than in 2020. So hanging around and seeing other stuff. How useful are the extension questions? Not very useful for Matt. They're just there because I wanted to put them there. The extension questions only exist because I had a kind of captive audience, right? We knew that people would click on things that say Matt, and then I sneakily used that opportunity to just show you some extra math stuff, sneakily. So the extension stuff is not really anything to do with maths. It's just because I find it very difficult not to tell people about maths. You've probably noticed that I'm doing too many tangents. So, we'll see. First stream was about 30 people at a time, I think. Sometimes like 20. It was really, really cozy. We switched to YouTube and now our numbers are doing slightly better. Not that the numbers matter. I've always said that I'll keep doing this stream until it's no people. There is a great history of mathematicians lecturing to 0 people. Isaac Newton has done it, lecturing to 0 people. When it happens to me, that's when we stop. At the moment, we are not quite at 0 people. Good, okay. Here's the math question. Goodness me. Also in 2020, we used to edit them down. We used to take the live stream and then edit out all of the banter and all of the chat to do a kind of maths only edit. But it's really depressing because you'd cut down your 2-hour live stream and you'd end up with about 20 minutes of content, and you'd do the edit and just think, what was I doing for the other hour and 40 minutes? I'm using 2 hours of everybody's time and only doing 20 minutes of stuff. On that note, let's talk about MAT 2013, question 3. We're told that k is some number between 0 and 2, and we're shown a graph, which is nice. We don't have to draw it ourselves. Sometimes in math questions we are asked to draw graphs. This is not one of those times. This is y is f subscript k of x, where fkx is defined as x multiplied by x minus k times x minus 2. Okay, there's a lot to take in here. Full stop. We're going to pause before we read the next sentence and think about what that means. This notation is a little bit funky. It's sort of like a sequence, maybe. But it doesn't really make sense as a sequence, does it? Because k is some real number between 0 and 2, so it doesn't quite make sense as a sequence. I'm going to write sequence anyway, because you can think about these as different functions. For every number between 0 and 2, there's a function. So there is an f1 of k of x, but there's also an f 0.5 of x. These are different functions where the number kind of lives down there. It's like naming your functions f1, f 0.5, f 1.9 or whatever, f of pi over 2 of x. Which is a little bit odd, a little bit stuff to get your head around. If we get scared of this notation, though, we've been given this way out, that they've told us that it just means, it's going to mean, I think throughout all of this question, x multiplied by x minus k multiplied by x minus 2, which is a cubic. I always write on questions. You get some blank paper in the maths, in the booklet to write your answer on. I always write over the questions as well. I can see the roots, they're at 0, k, and 2. And in fact, the picture's got roots at 0, k, and 2 as well, so that's good. Good. Please do not make the mega cut of me getting distracted. If you do make the mega cut, then this can be the first clip. Good. Okay. Right, I didn't read the second sentence. What was the second sentence? Let A of k denote the area of the shaded region. Okay, we're going to be super careful here because this area of the shaded region, there's this relationship between integration and areas. It's a little bit fractious, a little bit complicated. Integration gives you the signed area. It's either positive or negative. When you integrate, you get back, you get back a positive thing if the function you integrated was positive, and you always get a negative thing if the function you integrated was negative throughout the region. areas are supposed to be always positive. So when they say area, they mean add up some positive areas, please. So that's what's going on here. This question does have several parts to it. We're currently looking at part 1. Good. Without evaluating them, write down an expression for a of k, that area, in terms of 2 integrals. Okay, so I mean, it helps a little bit if we're told to do 2 integrals and to think about this area. There's this rule for areas. If your function changes sign, you're supposed to think about those regions separately. That's just a rule that somebody told me at some point when I was learning about integration and areas. We're going to revise that in a future live stream in a couple of weeks' time when we talk about integration. But hey, if this is news to you, the thing we're going to do is we're going to integrate from 0 up to k. What am I going to write? I'm going to use this weird notation they've given us. That much integral plus, so that's the bit from 0 up to k, this bit of area, where the function's positive, so we're okay. We can just integrate. We are okay, integrating from O to k. And then for the next part, I'm going to integrate the function, but wait for it, I'm going to remember that I need to, this will be negative. I could put mod signs around this, or I could just put a minus sign out the front. Okay, so I know when I integrate from k to 2, I get a negative thing that's something to do with the area. It's the signed area. It's exactly -1 times this bit of area over here between k and 2. I'm going to colour code my picture while I catch up with chat. So you can't just do the absolute value of the area overall. You can't just do this because the integral will let you down. Some of it will cancel out with other bits inside before you take the absolute value. Before you take the absolute value, some of it's already cancelled out, and you've already lost that. It will work out this bit of area, it will work out something over here, it will get back down to 0, and then it will work out a bit more negative stuff. And you'll have lost all of the information about all that lovely area that's cancelled out. So you've got some options. I've left it around with some brackets. I've put brackets around to make it clearer what I was doing. I'm going to put some colour coding on here. Of course, you are free to do some algebra if you want to now. You could do things like multiplying out. So I could have written a minus sign in the middle, but I know that chat will, you just would be confused. It would be confusing as a presentation if I just wrote it out with a minus sign. But yeah, you're now free to go manipulate this by writing it down with a minus sign in between these 2 integrals if you like. Or I saw someone else in chat asking about flipping around the limits, which is fine as well. There's this rule of integration that instead of integrating from k to 2, you can integrate from 2 to k if you put a minus down at the front. To see why that is, imagine doing the integral and having some square brackets for where you're about to plug in the limits. When you plug in the limits, you do top limit minus the bottom limit. So if you switch the order there, then you'll do essentially bottom limit minus the top limit, which is the same thing but flipped with a minus sign. Good. You could put mods inside, but they would be awkward to deal with, and I know what sign the function is. I can see from the picture that it's positive between 0 and k, and it's negative between k and 2. Right, good, okay. Oh, have I picked somebody else's colour coding? Oh no. Good. Good. We then run it. We're doing this. We've got 2 integrals. Am I going to tidy it up? I think I'm going to tidy it up a little bit. I don't think I need to tidy it up. I've written down 2 integrals. Having a lovely time. I think I'm going to put a minus sign in between. I could write in the definition there in terms of what I know what fk of x is. Sort of quite keen to just go and calculate, but it says without evaluating them, so you know, okay. So these things are polynomials. Cubics. We're now going to explain why this is a polynomial in k. Polynomial in k. Well, I suppose after you've done the x integration, it's not a function of x anymore. It looks mysteriously like it. It looks like a function of x, right? Because it's got x's insides and outsides. But when you do the integration, it stops being a function of x. You kind of integrate out all of the x's. You plug in these limits for k. Okay, so when I integrate, let's write down something like fkx is a cubic in x integrates to a degree 4 polynomial in x, and then when substituting the limits, get a degree 4 polynomial in k. I would, because it's a pain to write on this graphics tablet, it's a pain to write full sentences on this graphics tablet. I haven't. If I was writing on paper, I can write faster on paper. I would probably write full sentences for this bit. They do say degree 4 or less, but yeah, I guess we get a degree 4 polynomial. If I'm being really careful, I would say for each integral. For each integral. How do you spell? Oh my goodness. Each integral, the difference is a polynomial of degree at most 4. There's this technical thing that the question writer is being careful about, where this first term integrates up to a 4th order polynomial in k, and the second term is also a 4th order polynomial in k, and usually when you do the difference between those two things you end up with a 4th order polynomial in k, but sometimes the k to the 4 term cancels out and you're left with technically something that's not a polynomial of degree 4. Degree is the highest power. Yeah, cool. So you integrate, when you integrate x cubed, you get x of 4. You plug in k, you get k to the 4. Good enough for me. Yeah, there might be some cancellation going on. Absolutely correct. This anonymous person, yeah, just trying to say. Good. I don't understand what the wording means. Oh, degree 4. There's a polynomial episode coming up in the future. It means that the highest power of x is 4 or less, and in k. So something times k to the 4 plus. Here's a polynomial of degree 4, highest power. Cool. Who marks the map? Good, right. I think you get a couple of marks for this. I think we've got a few marks so far, but most importantly, we're still going. We haven't given up yet. And I think it's better to think of marks in terms of just you're progressing through something. The further you get, the better. I don't think we've been defeated yet. We're still understanding things as we go along. The setup's pretty weird, I guess. It's got this function. There's something going on, but so far, we're just writing down a fairly normal thing for integration. It's got this variable k in it, and then we've kind of maybe slightly blagged our way through explaining why it's a polynomial in k of degree 4. Here is some work, and this is quite a lot of work. So we're going to get some more marks here. This stage might defeat us. What do I mean by substituting limits? Oh, so when you integrate, yeah, I should probably have written more words out. When you integrate up to get a new function, and then you plug in the top limit and the lower limits. There's probably a phrase for that I've forgotten. I could maybe bring in some algebra or something. Call it capital F and say, capital F of k minus capital F of 0. Yeah, actually giving things names is a really powerful technique. Let's talk about this. Call it big F of x. Maybe subscript k, can I be bothered, can't be bothered. When substituting limits, f of k minus f of 0, you get a polynomial of degree 4 for each of the integrals. I guess the other one is a different function f, or maybe the same function f. Good. Yeah, well, that's quite a nice way to think about it actually, because then this is f of k minus 0, f of k minus f of 0, take away f of 2 minus f of k. It's kind of more clearly f of 2 times f of k minus f of 0 minus f of 2. Huh, right. Is that enough to write for the marks? I would err on the side of writing full sentences, but I think we've got the key ideas, so that would be good. Okay. I would give myself marks for this. I'm a very generous marker. I'd give myself loads of marks. Brilliant. This just in, James would definitely admit himself into Oxford. Right, here's a really complicated bit of question. The thing on the left here, f subscript k of 1 plus t, we can engage with that, right? Because that means substitute in 1 plus t. Wherever you saw an x before, write 1 plus t instead. And then on the right, we're going to have to think quite hard. But let's do the left-hand side first. So this f subscript k of 1 plus t, that means 1 plus t times 1 plus t take away k times 1 plus t take away 2. Okay, well, all I've done is I've remembered what f of x was way up here, x minus k, x minus 2, and I've replaced all of the x's with 1 plus t's. I think I've done that correctly. Good. Okay. The other thing we've got to understand is minus f of 2 minus k, function applied to 1 minus t, which is quite a brain-melting sort of thing. One thing's clear, we're going to replace all the x's with 1 minus t's. Something else that's also clear, I suppose, is there's a minus sign out the front. I can handle both of those things. I can start going, actually. I've put the minus sign down, I've put the 1 minus t in here. Then the next bit of f is there's an x minus k, except it's not k anymore, because this function has got where the k used to be in our definition of f subscript k of x. It's now 2 minus k. So I'm supposed to be writing out the definition that I remember from the top of the page, but replacing all of the x's with 1 minus t's, and replacing all the k's with 2 minus k's. So I'm going to write minus 2 minus k in this next bit. Oh my goodness. Okay, phew, goodness me. What a lot of terms. This doesn't look like it could possibly turn out to be the same thing in that first line and the second line. But after doing a bit of manipulation, rearranging some terms, it turns out that it is. Let's do that now. We can simplify some brackets, yes. So I like to two-step. First, be really careful to write out what I get when I kind of naively do the substitution. And I wrote something that looks a bit stupid, like 1 plus t minus 2. But then I'm going to do the algebra as a kind of separate processing step. I've trained myself to do those as separate steps. You often see me skipping out steps and going really fast, but I've trained myself to do this sort of thing as separate steps because it's easier to check for mistakes if each line I'm doing one thing on complicated steps. I will limit myself. Rate limit it. Okay, haven't thought of anything clever to do on those first two brackets, but this one over here is then t minus 1. I think it's what the person in chat says. Oh yeah, Kai said t minus 1 in chat. Brilliant stuff, love it. I can probably do a lot of work over here. I'm going to bring in that minus sign into the first bracket. It's pretty tempting to do that because, well, it gets rid of the minus sign up front, and also this t minus 1 looks quite familiar. What have we got over here? A whole bunch of minus signs. And a k minus t minus 1. And this is minus t minus 1, goodness me. Which actually, don't give up, don't despair, because these two brackets look completely unfamiliar, but they look unfamiliar. I want them to turn out to be these two brackets from the first expression from the left-hand side, and actually they are. They've just both been multiplied by minus 1, and that's okay. We can flip things around like this. If we multiply both of them by minus 1, minus 1 squared is 1, so we're okay. So these things are the same. Good stuff. Factoring out negatives. In fact, it's kind of every bracket was negative, so there are kind of 4 minus signs going around. Doing this sort of algebra and doing it algebraically is, I think, a good way to make progress with it. Good way to get in with the question. Note that if you're happy doing manipulations like this, then you could even have skipped the first two parts of the question and come down to this part and just done some substitutions. I don't know why you would do that. The first two parts are not that bad. But jumping in this part, you can pick up some marks like that. That's fine. You can jump in and go through. Doing both without looking scruffy. That's a kind of good question, I guess. Leave yourself a bit more space. I have not left myself enough space to do this without looking scruffy. Looking scruffy is kind of my kind of house style, I suppose. You can jump through and get marks later on. Maybe picking up some marks like this. There's probably a way to think about this in terms of graph transformations, to think about what happens when you do these. What's happened here is that the t on the left has kind of been replaced by a 1 minus t, and the k has been replaced by a 2 minus k, and there's a minus sign. I'm saying this because a couple of years ago I tried to explain this math question in terms of transformations like that. It was a bit of a disaster, but secretly what this is saying is that if you replace k with 2 minus k, so let's draw two pictures. I'm going to have another go at the disastrous explanation. If you replace k with 2 minus k, then not much changes. The graph still goes through 0, it still goes through 2, but now it goes through 2 minus k. So that's a bit like a reflection. The position of the roots has sort of been reflected and translated. It's done a reflection and a translation. It's moved around like that. But the graph overall hasn't done a reflection, it hasn't flipped. So there's this extra minus sign out the front to try and flip the graph back into happy cubic territory, so that's going up for positive x. That explanation is not very good though. You can also imagine this as a one big rotation about the point 1, 0, but that's definitely too much. This is not the only space you get. This is a special version that I've made for the live stream. This is not all the space you get. Come on. This is going all right so far. If I have real bad handwriting, will they throw away my test? No. We will do our best to mark it. If we can read it, we can mark it. Yeah, it's a bit like a reflection in x equals 1 and then a reflection in the x-axis. Reflection in x equals 1 is not technically on the math syllabus because it's a non-trivial reflection like that. Yeah, translation. Yeah, replacing x with 2 minus x, but that's not even quite what's happened here. Good. Could I re-explain part 2? I'll re-explain part 2 just for you. We imagined doing the integral. They told us not to actually do the integral, but we had a really good imagine of what would happen if we tried to do it. The things inside, they're complicated, but they're just cubics. When you integrate cubics, you sort of know what's going to happen. This part of the question is trying to give you marks for sort of knowing what happens when you integrate a cubic without making you actually go and integrate the cubic. Good, okay. It is a rotation rebel, yes. Yeah. If k is between 0 and 2, then 2 minus k is also between 0 and 2. Good. Right, good. Okay. Right. Why can I do the questions before the live stream, but then I get distracted during the live stream? I feel like that as well. One person said thank you. I'm going to believe that it was the same person who wanted that part. No, actually, it's more fun if I believe it was a different person. Good. Yeah, Denim, yeah, you can practice. I mean, there's no harm in looking at the other questions, 4 and 7. Sometimes they're quite fun. And hey, having a bit of variety is probably good for you, but they're not as directly relevant, I suppose. You should be able to do them though. I feel like people should be able to do all of the questions, and then the actual questions they're doing are just part of which degree they're applying for. But I kind of feel like people should be able to have a go at them. Right. Yeah, you normally can get part credit. This question on screen, technical marking question, you can normally get part credit. Right, good. They are now going to make us think about transformations. Was this on screen while I was talking about the transformations and explaining how it's really difficult to explain the transformations? Here we go. Okay, so part 4 is, I suppose, wants us to get towards, this is why I had to talk about it in 2020, isn't it? Flashbacks. Wants us to talk about how fk of x is related to f of 2 minus k of x. So this way that the graphs are quite similar. But there's some combination of transformations you can do to try and turn the first one into the second one. The most obvious thing is there's some sort of squashing, or some sort of squashing that moves that root from k over to 2 minus k, but that doesn't really work because that squash would also move around the root that's at 2. So you can't do a squash quite like that. You can do a rotation by 180 degrees, and it turns out that's perfectly correct. You can actually do a pair of reflections instead, or if you're not happy with reflecting in the line x equals 1, then you can think about it as a translation, a reflection, a translation, a reflection, to be that combination of 4 things going on. The punchline for part 4, I suppose, is that it's just been rotated, so the area is the same, because areas are the same after rotation, or same under reflection. Why don't I make everyone do all the questions? Yeah, fair, good idea. Can I be a math researcher and a professor at the same time? Professor is a job title, and maths researcher is a job description. Yeah, some people do that. Can I do IMO problems on the stream? No. 3 we just did the algebra, right? 3 just happened. We did all the algebra. It just happened. We plugged in all the stuff. The tricky bit was plugging in 2 minus k. It's 2 minus k, which got plugged in over here. That was maybe conceptually the hardest bit. The thing to understand, we'll move on very, very soon. The thing to understand, I suppose, is that when you're given a definition like this, it just means that you can replace x. Whenever you see an expression that's this shape, you can replace the thing inside the brackets here, here, and here. This goes here, and here, and here, and the thing k goes over here. Let's do that one in a different colour. We're using colours today. So you're really set up. You know that f subscript alpha of beta would be beta minus alpha, beta minus 2, and stuff like that. And if you're not happy with that, then try to find a way to convince yourself that nonsense like this is true. That really we're just doing sort of substitution, replacing one thing for another thing. We've even got, this will make everyone upset, but f subscript x of k is k minus x, k minus 2. That's guaranteed to make people unhappy, because I sort of swapped them, but not really. If you don't like that following from the thing in the question, then imagine the alpha beta thing first, and then imagine a different substitution afterwards. So it's like a stepping stone in between. So there we go. Good. Okay. Hey, a tutor is here. Right. Good. Okay. Could you say the interval 0 to 2 is reflected in x equals 1? I think it is. Yeah, I think that's good. Can I add more reflections to the worksheet? So reflection is a stretch by a factor of -1. And they're included in the stretches. You're right, I can make that more explicit in the worksheets. I think for future, reflection on reflections, I need to put some more text to make it clear that people are thinking about reflections with these minus signs around. It's multiplied by -1, right? Okay. Yeah, good, okay. People will hate that. Right, aphantasia conclusion. So last week we talked about aphantasia. I said I would go and look it up. I was lazy. I read the Wikipedia page, and then I thought I really need to look this up. And then I took a week off. I've actually had most of this week off, so I haven't looked up aphantasia yet. Sorry. If I don't understand the notation in an interview, you can ask for translation into usual notation. In an interview, yes. In MAT, no. I think there's no one to ask. Good. How do you know the rotation doesn't affect the graph? Yeah, 2020 flashbacks. So, I know that it's a cubic. How do I know it's a cubic? So rotation is a pair of reflections, really. I've started to think that doing it as a rotation is not a helpful way to imagine it. Imagining it as a pair of reflections is more helpful. Also because it's a little bit more obvious when you do the algebra that pair of reflections first stretched by a factor of -1 and then stretched by a factor of -1 in that direction. A pair of reflections, algebraically, I think it's more obvious that will give you some sort of cubic, and you can track through what the roots are. Yeah, should we think about that pair of reflections? Is that a helpful thing to do? Okay, this is a little bit of a tangent. We're going to come back, but to help you see, the important thing for today is not really whether you and I can get the marks on part 4 of a math question from a decade ago. We can't, because the test was a decade ago. I think the important thing is that we use this time to get more happy with the kind of transformations. And people are asking about reflections under here. There's a great question at the top there, which we should do. Yeah, good. Carl spotted that it's Romans. No. They are Roman numerals on the test paper. It's a bug in the way I produce my worksheets. Right, good. Okay. We're going to come back to this part 4, and we're going to talk about transformations. Yes, rotations as pairs of reflections. Part 4. Yep. Okay, here we go. Haven't really talked about part 4 at all. Okay, so I'm going to quickly explain. I'm going to write it like this. I think it's just nicer. Do you want me to write the K on? I'll write the K on. Fine, I can hear you asking for the k. Okay, so first I'd like to show you what happens if we think about minus, I'm going to build up to minus f subscript k of minus x. And I'm going to try and draw the pictures as well. So first if I plug in minus x, ooh, minus x minus, come on, there's a button here that I shouldn't be pressing. Minus x minus 2. Okay, that's a pretty mad string of things. I've replaced all the x's with minus x's. Remember, that's what this thing inside the brackets means. It means wherever you see an x, you can replace that everywhere. So what has that actually done? It's given me a new cubic. I can simplify this one. It's got kind of 3 minus signs going on here. What can I do with that? X plus k? Kind of want to simplify everything, right? I think that's true. Good, yeah, that's true. So my graph before, it looks like this, 0, k, and 2. And now f subscript k of minus x has now got, it's a cubic with roots at 0 and minus k and minus 2. And when x is really big, all of these terms are positive, and there's a minus sign at the front. So it's a cubic like this. Okay, so go through the origin. A cubic like this. So that is a reflection, which is what we thought it would be. So that's nice. It's nice that the algebra checks out. This is a reflection in the y-axis. Okay, I'd like to do a second transformation. I'd like to now think about minus fk of minus x, which is just to put another minus sign into things. Out the front, which as you can, is just going to get rid of that minus sign out the front there, isn't it? So that's a cubic that has roots at minus 2, minus k, and 0. And what else? What else can I say? Oh, it's the sort when x is really big, it gets really positive. So what I've done now is, as a result of those two reflections, I've got a cubic that it's kind of quite similar. I mean, it's still a cubic, but it's actually being rotated around. It's not very convincing, is it? It's being rotated. What's a more convincing way to convince you that two reflections make a rotation without using any matrices? We do something with a bit of paper. Yeah, grab yourself a bit of paper. This is a symmetries question, isn't it? I'm just trying to find a bit of paper that doesn't have anything confidential written on it. This is a symmetries question. We should be doing this with a camera. Okay. Two reflections make a rotation. Here we go. Switching to the real world now. Okay. Here's my business card. It's the only non-confidential item in this office. I'm going to do two reflections. I'm going to do a reflection in the y-axis, and then I'm going to do a reflection in the x-axis. And I hope you can see my business card is being rotated by 180 degrees. I'm going to do it one more time. Here's my business card. I'm going to reflect it one time, and then I'm going to reflect it again, and it's been rotated 180 degrees. Goodness knows if that's convincing or not. Two reflections make a rotation. That's also what's happened with this cubic as well. It's been rotated around as a result of those two reflections. The one in the actual question then wants to do a translation by 2 units in the x direction, so the roots go to 0, 2 minus k, and 2. But that's precisely the cubic that goes through 0, roots at 0, 2 minus k, and 2. That's f subscript 2 minus k of x. Good, okay. If I factor out some minus signs, I think everything on this screen is correct. Good. That's rotation around 0, 0. Good, good, good. What does James have that's confidential? You know, a lot of stuff. Rotate the board. Okay. I'd have to fix the... Yeah, I know. Okay. Right. Okay, right, good. So, one possible answer for this thing in question 4 then is to realise that if you do this pair of reflections followed by a translation, you end up at this graph. You end up at this cubic with roots at 0, 2 minus k, and 2. I'm not really sure how you could possibly have spotted that other than by messing around with some algebra or by thinking really hard about how to transform the string of, the string of where the roots are, to transform that I guess I might have thought after a while that 2 minus k, that distance between 2 minus k and 2, that distance is k, so it's sort of like being a stick that's been rotated around. The card rotations actually helped, that's good. The rotation was about the origin, yes, for both the card and the cubic. The origin stayed fixed at the origin for the cubic down here, and for the middle of my business card over there. I'm now slightly regressing. So my business card got anything confidential on it? No, it's got a link to our Facebook page. Make sure to follow us on Facebook and Twitter. Oh, and the main YouTube channel. Oh no, it doesn't even have the YouTube. It doesn't even have the YouTube channel on. Right, good. Okay. The translation right is that this last part where the function I'm actually trying to get to, this translation at the end, is f of 2 minus k, which means the cubic that goes through 0, 2 minus k, and 2. That's what this thing means. Because it's x minus 2 minus k, x minus 2. That's just what these functions mean. I guess being able to switch into the description backwards and forwards. Okay. Good, right. Compound transformations. Really tricky. Okay. And final part here is algebra again, I think. Explain why there are constants a, b, and c such that this area calculation that we didn't actually do is equal to this expression. You are not required to calculate a, b, and c explicitly. So one approach, although it says you are not required to calculate a, b, and c explicitly, one approach is to just say we can do this integral. We're just being told to integrate a cubic to find a 4th degree polynomial. We said it was going to be a 4th degree polynomial. Now here we are doing the finding out which 4th degree polynomial is, and then simplifying our answer at the end. That's an idea, and if you're quite confident at doing integration, then off you go. You can have a go at that. So being able to spot that is pretty good. It is a hidden quadratic. That's true. Can we spot that it's a hidden quadratic before? Maybe. Crucially, I think so. A slightly faster strategy is something like this is very general. This is a degree 4 polynomial that's been translated. I mean, you can always translate a polynomial, right? You can always translate a polynomial. The special thing here is that it doesn't have a cube term and it doesn't have a power of 1 term. So I suppose we already knew. This is not obvious. We already knew that a is equal to small a of k minus 1 to the 4. Where are we going to write this? Here we go. Plus, I need to use a different letter for this bit. A plus b times k minus 1 squared plus some other number times k minus 1 plus c. We already knew that because we knew it was a degree 4 polynomial, and you always have the option to write your degree 4 polynomial like this by doing something a bit strange, which is translate. That's still a degree 4 polynomial after you've done the translation. Find out the coefficients of that polynomial after you've done the translation, and then write it down in terms of that translation. So that's a bit weird. We're being asked to prove that these things are 0, and we can use part 4. If we use part 4 and just plug in the facts that we know, this is a of k. A of k is equal to a of 2 minus k. And then do a bunch of rearranging. Then several things cancel out. The ABC terms cancel out on both sides of that equation, and the alpha and beta terms are both still there. And this is true for all k. So the coefficients have to be 0. So minus f of minus x is a 180 degree rotation about the origin. You can tell because the origin point when x is 0 is still at minus f of 0. No, yes, good. If y was 0 at x equals 0, then it's still 0 afterwards. Right, okay. Yeah, so for part... oh, hello. For part 2, you may not say that part 5 says it's a degree 4. You can use previous parts, you can't use later parts. Otherwise, you get into this kind of circular reasoning thing. Yeah, okay, we know it's a polynomial in k-1. It's an even function about k-1. Yeah, if you want to write that, if you want to say things about even and odd functions, then yep, sure. I think we've shown it's an even function. If you know that language, then you can say that this says something about even and odd functions. Okay. Yeah, I think this question was quite hard. In particular, I think it's easy to pick up some marks as you go through with the algebra at the start and the integration. I think it's quite hard down here to describe those transformations. I don't enjoy doing that on the live stream each year to try and explain all those combinations of transformations. I think this is a good practice problem to do on the MAT live stream because you've got these kind of combinations of things to think about. I think it's probably a little bit hard for the MAT. And then at the end, being able to write it in terms of k-1, I think it's just a bit too much. Maybe in that I can tell you it's true, and you can even probably go and convince yourself it's true, but I'm not sure how many people thought of that live. Oh, is that a slider version of this? Good. Okay. Yeah, why are they all in k-1s and not k's, right? If we left you to your own devices and you wrote down a degree 4 polynomial, you would have written it in terms of k to the 4. Usually, if you don't know the coefficients, you always have the option to write it down in this format. So it's not a very commonly used fact. Yeah, why k-1? What's going on? Why have you done that? Always can. Yeah, you always can. Because once you've translated your degree 4 polynomial, it's still a degree 4 polynomial. So some people in chat are saying, have MAT papers gotten harder? I think this question's quite a bit harder than anything on MAT 2020, I think. I don't know if it was popular because I was not around in 2013. This is before my time in Oxford. So cool. I did not have to deal with any of the emails that came in after we set this question back in 2013. Good. Yeah, it helps you plug in the emails too much. It joins everything together. That there's possibly a different version of this question where let's talk question design really quickly. The question's slightly harder by being between 0 and 2. If you took this question and you replaced the role that 0 and 2 are playing, if you replaced it with 1 and -1, then you get a question that's easier to deal with, partly because all the cubic stuff simplifies, so you could it would be easier maybe to do these integrals if you wanted to. There's some difference t-squares stuff going on in there. So it's easier to deal with it algebraically. It's also easier to describe the transformations because things are then more symmetric about the origin. The punchline for part 4 is just rotation about the origin or pair of reflections. All of these 2 minus k's become just minus k's, so the function is kind of genuinely even in terms of k. And then in part 5 it would be the more obvious. It would be expressed in terms of k to the 4 and k squared. At the end it would be genuinely an even function in k. So there's a translation issue here. That there's a nice kind of straightforward question in a way that's been translated 1 unit to the right, and then it's become a bit harder to work with because of the translation 1 unit to the right. Yeah, cool, good. Goodness me. Those final transformations. How do I know? Yeah, so I think 2 things to think about, I suppose. Is it true that you can always write stuff like this? So if I give you a quadratic, the normal way we write quadratics, the degree 4 thing also makes this a bit harder than it maybe has to be. The normal way you write quadratics is like this. But what's special about that? Not a lot special about that. You could have learned all of your quadratic theory in like Bizarro universe version, where everything's a slightly different shade of blue. You might have learnt about quadratics defined as, maybe we use different letters, as like p x minus 1 squared plus q x minus 1 plus r. And loads of stuff, you'd be amazed how much stuff still works over in Bizarro universe, where everything's got factors of x minus 1. That's still a quadratic. It's a bit of a weird way to write a quadratic, but not that much stuff goes wrong. Good, okay. Why did I apply to Cambridge? Yeah, goodness me. Oh, did I really write 1 less than k less than minus 1? I did! Oh, that's so annoying. It deserves that many question marks. Okay, I meant the minus sign over here. Oh, give me a break, chat. Yeah, the question's much easier if there are no values of k involved. If you define the inequalities, you see, so that there are no functions that satisfy that inequality, then we're asking questions about no functions. Oh, yeah, there we go. There's chat catching up with me. Right, good. Okay. Yeah. I did use parts 1 to 4 in part 5. I used the fact that I already knew it was a degree 4 polynomial from part 2, which used part 1, and I used the fact, I didn't actually do this stage on the screen, but I'm about to use the fact that a of k is a of 2 minus k, which is part 4. And I'm going to plug that in algebraically, and then argue that out from beta pretty much 0. Let's do that step. Bruce has asked for that step. Oh no, Bruce has just said the phrase giga chat. Chris has asked for that step. I'm going to do it. It'll take 2 minutes, he says, looking at the clock. It's about 6:30. We're going to do some short questions after this as well. Ooh, do I like this backwards format? I think it's good. I think it helps with doing useful things. Okay, so maybe you're going to take it on trust for now, and then go and think about it at home after the stream. Not many live streams give you homework, do they? Eating into my 2 minutes. But maybe more live streams should have homework. Maybe they should do their Super Mario really fast and then be like, homework. You need to go and learn how to do this particular shortcut as well. Good, right. Homework. Convince yourself that you can always write a degree 4 polynomial like this. If you really want to in Bizarro world, you can go and do that. If you take this as true, then you can also write down a of 2 minus k. Which is an interesting thing because we just showed in part 4 that a of k is equal to a of 2 minus k. So this is going to be really powerful. 2 minus k, take away 1. No, I'm going to go for it. I'm going to speed run. The thing that I said I wouldn't do. So I'm plugging in 2 minus k, but then subtracting 1. So I'm writing down 1 minus k, which is not too bad. Plus beta 1 minus k plus c on the end there. I'm behind chat. Plus c at the end. So it's a very similar looking expression, except all of the brackets have, because I've done 2 minus k. That is 2 minus k minus 1 in each bracket. But 1 minus k is the same thing as k minus 1. So actually this is k minus 1 to the 4 plus. Oh wait, hang on. So this is k minus 1 is not the same thing as 1 minus k, is it? They're out by a minus sign. There's minus alpha k minus 1 cubed. Plus b, and then that is k minus 1 squared, minus beta k minus 1 plus c. So when I set these things equal to each other, because I know that a of k is equal to a of 2 minus k, then I get a bunch of terms that match up on both sides. But I also get alpha k minus 1 cubed plus beta k minus 1 is then supposed to be equal to, by part 4, that's supposed to be equal to minus alpha k minus 1 cubed minus beta k minus 1. That's clearly nonsense. Unless alpha is 0 and also beta is 0. That's a cubic on each side that's equal to negative itself. No cubics do that except the 0 cubic. Okay, good. Right, good. Okay. Yeah, okay. Transformation into 2 minus k, we've talked about it a bit before. It is this combination of things that are going on plus a translation at the end. So it's a rotation about 1, 0. But you can also think about it as a series of reflections and things. Okay, long question. I think we've had a good chat about long explanation. Oh, thanks, Chris. Yes. You do things for one person, and then that one person is actually a human who's watching. This is why we do the stream. Right, good. Okay. We're going to do some short questions. We're going to quick fire them, and we're going to turn on some polls to get people involved as well. It's called engagement. How do you do it? Right, okay. Here's some short questions. So I think normally people do the short questions before the long questions when they actually do the math, but maybe that's something I should ask the first years. Maybe I'll go on TikTok and see if I can find any first year students. So here's a math question. It's asking about the number of regions that the plane is divided into when we graph these. It doesn't actually tell you to graph them, but you probably should. I'm going to start doing that now. So x cubed looks like this. Oh my goodness, in it comes, and then out it goes. X to the 4, so between 0 and 1, that's like multiplying x cubed by something that makes it flatter. Multiplying x cubed by something small, so it's going to be smaller. When you get to 1, they're both 1, and then it's bigger. That's my x to the 4 picture. I'm going to really struggle with x to the 5, aren't I? It's also positive. Oh my goodness, that's one of the worst things I've ever done. You can have a compass and ruler for maths, I think. Pretty sure that's the rule. Right, x to the 5. I'm going to do the negative bit first. Really negative like this, and then flump. Really suddenly. So x to the 5 is great because in between 0 and minus 1 over here, and actually out to 1, you've multiplied by a small number now so many times that you get something that's almost 0. for most of it. But I know it also goes through 1. And then I guess it's going to be, after that, it's going to be even bigger than x to the 4. This is my x to the 5 picture. This is one of the least convincing things I've ever sketched. Your sketch at home has got to be better than this one. This is terrible. Look at the way it goes left. What am I doing? Oh, if you can work out what I'm doing, then boy, goodness me. Okay, other points that the graphs go through. There are 2 graphs over here. All 3 of them go through the origin. I think all 3 of them should be going through that point 1, 1. And then there's a counting step of this question, which is also not very nice. The axes don't count for splitting things up because we're just thinking about these 3 curves. So let's erase the axes. Just try and count the regions that this is split into. It's a bit difficult, isn't it? There's some really big regions and there's some really small regions. There's a couple of fiddly small regions over here. I can see some big ones over here. I'm going to go to chat and find out. X to the 5 is not supposed to overlap onto itself. What does chat think? Chat has done some counting, and chat thinks that only a few votes in, but it thinks it's 71% voting for D as this being 9 regions. Let's try and count them on screen. There's 1 up here, 2 over here, 3 over here, and then there's 4 over here, 5 for this big region over here underneath everything, 6 and 7 inside here, and then I guess I've got 8 and 9 over here. I've also got D. Good. I agree with chat. There we go. And 69% of chat agree with that. No, 70%. Good. Okay. Small and large values of x are key. I think I agree with Rabil in chat. Okay. Good. It does not go back on itself, x to the 5. It doesn't curve left. My picture's terrible. Yeah, okay. I started counting, it started becoming more and more D, and it went down. Right, good. Okay. Let's look at some pictures. There's a style of math question that I quite like. I'm not saying that as like a clue or something. I just genuinely enjoy this. Where this is how we do graph sketching questions in the multiple choice questions. We can ask you, rather than sketching the graph, here are 5 attempts at a sketch of the picture. Which one of these is correct? Which one's right? If you haven't seen logarithms before, if you've never seen logarithms, then sit this one out. This question clearly involves a logarithm. If you haven't met logarithms before, this one's not going to make any sense to you. So we'll need to think about something different. Kai is linking to a Desmos thing. Does moderate. Oh, it's a picture of some regions. I love that. Thank you, Kai. If you're watching the replay and you don't have access to Slido, then it's going to be really hard to try and see these lovely Desmos pictures that people are putting because they're typing them on screen. Copy down those things as well. Right. I'm babbling away because you've got a chance now, if you're playing along live, to have a think about which one of these graphs is log base 10 of x squared minus 2x plus 2. I can think of several ways to get started. One of them is to start thinking about logarithms, and one of them is to start thinking about polynomials. Bruce in chat would like to complete the square, so Bruce is thinking about polynomials first. Yeah, I guess you could complete the square. I saw a YouTube comment in the last week of somebody putting on YouTube that they hadn't heard about complete the square. So we're going to do that in a second. If you haven't heard about complete the square, then we're going to change your life with quadratic equations. Change your life. Sorry, we're not going to change your life with quadratic equations. We're going to change the bits of your life that involve quadratic equations with quadratic equations. Oops, hang on a minute. There we go. If you already voted, sorry. I turned that poll on wrong. Let me just fix the other one as well. Okay, we are voting. There we go. Polling. Poll. If you haven't completed the square before, it's the process of converting a quadratic like this one into a quadratic like this one that, when I was at school, we just learned how to do this at some stage. Can't really remember when. The way I do it is to think carefully term by term. Here I've written an x inside the bracket. I always want something that's this shape. If there'd been a 4 out here, then I would have written a 2 in here because I know what happens when you square 2x. I have to think about square roots a little bit. I like to put the number inside the bracket as well. And then I have to think really hard about writing down a 1 here so that when I cross multiply out, I'm imagining multiplying out the square as I go. Probably some people know a formula for this or know some mnemonic with some rhyming words in it, or an acronym or something. I don't go in for those sort of things normally. I just sort of rely on my ability to multiply out brackets, which doesn't always work. When I square out this first bracket, I'll get a +1, but I want +2. So I write down an extra +1. It's called completing the square because I've ended up with a square. I don't know. Poll. Can I zoom out? Oh yeah, sorry. I zoomed way in on that algebra. There we go. You want to pick a graph. Quadratics is good because now we've got some idea of what's going on. I know that quadratic is definitely bigger than 1. When it's written as x squared minus 2x plus 2, that's some complicated combination of positive and negative terms. But when I see it's x minus 1 squared plus 1, that's the sum of two positive things, which is pretty good. It means that that's positive. Logarithms are pretty cross when you put in negative numbers. They don't like that. You should only really put positive numbers into your logarithms, please. So this is good news. This means that, in fact, this is only going to come down to being log of 1 at a minimum. Log base 10 of 1, what is that? When you learn about logarithms, you learn that log base 10 of 1 means the number that you would have to raise 10 to the power of to get 1. That's 0, I think. Because if you do 10 to the power of 0, then you get 1. I think. You can't see this in the replay. Behind the poll, chat is going crazy for complex numbers because some people watching know that you are allowed to do logarithms of negative numbers if you know about complex numbers. For the millionth time, complex numbers are not part of the MAT syllabus, so they are not on for MAT Livestream questions. Chat's doing very, very well at this question. I think chat has worked out not only that this is the minimum thing that the logarithm does, but also where it happens. There's B, which, who was it? Let's give credit to this one. B looks like a tick, which I really like. Who was it in chat? He pointed that out. Very nice. I can't find your comment anymore, but it was very funny. Good. Complex logarithms. Okay. Yeah, okay. Okay, so I think people are working out that this minimum happens when x equals 1. This minimum happens when x is 1, which is this picture down here for E. So for a quick look at the poll, yeah, chat's pretty happy with that. A and C and D have also got some votes. I can see why you vote for A. It's got a minimum in the right place. Wrong value though. I can see how that would happen. You plug the number in and maybe do log base 10 of 2 or something instead of 1. Complete square error maybe. People voting for C and D have got some asymptote spikes, so maybe they've realised that x equals 1 is the kind of symmetry point. Picking C, I can see how you would do that. People picking D, tell me in chat why you picked D. There's a couple of you picking D. So it is E. After all that, we're not adding complex numbers to the syllabus because not everybody learns complex numbers in time. In fact, complex numbers are on further maths, and some people are doing further maths not for ages. This question is quite easy, I think, because you can just plug in your favourite number. And I think if you plug in 1, yeah, if you plug in x equals 0 first to find out the intercept, then you get log base 10 of 2, which is some positive number. So it's not C, because that goes through 0. It's not D, because that goes through 0. Is one of the other ones. And then if you plug in x equals 1, you get log base 10 of 1, which, whether you complete the square or not, and then that's 0. So now you know that it goes positive thing down to 0. Oh, and that's picture E. So I think that's not too bad. Good. Okay. E is the only one that goes through 1, 0. Good. Okay. Good. Okay. We have 2 rules that I keep forgetting to say, which is welcome to the live stream. Please don't swear and please don't divide by 0. The only rules we've got going on. Okay, cool. We're trying to be. What are we trying to be? PG-13. What's the rating? But then there's more and more swearing going on everywhere else as well. Hi Precious, welcome to chat, welcome to the live stream. 20 minutes to go and only one short question left on this worksheet, so we might be talking about some bonus stuff. And somebody has asked me, James, have you seen this document? And then there's a mysterious shortened URL. Let me check. No, it's not a Rickroll. It's a Freedom of Information request. Yeah, okay, cool, right. Poll for this one? Poll. Let's have a look. Okay. We've kind of talked about this function a bit as well, so we're kind of coming around full circle. Let's turn a poll on for this function. It's the question in the thumbnail. So if you saw this video on YouTube and you clicked on the thumbnail because you thought the thumbnail looked fun, then sorry for exploiting the YouTube algorithm. We're now going to talk about the question from the thumbnail, which presents us with this function, y equals f of x. Doesn't tell us what the function is, just shows us a picture. And we are asked, which one of the following 5 things is minus f of minus x? A sketch of y equals that. So we've got 2 minus signs to contend with. I think this is something like a reflection in the x-axis and a reflection in the y-axis. Doesn't actually matter which order you do those in. And we talked about earlier with my business card, we talked about how that's the same thing as a rotation, which I'm not sure I would expect you to know going into the MAT exam, except now that I've told you, I would expect you personally to know. I'm not sure I'd expect people generally going into the exam to know. I'd expect you to know, because I just told you it twice. So I guess this question is which one is a rotation? We learnt a fact. How else could we approach this? I suppose we could notice that in this it looks a bit like maybe f of 1 is not defined or is infinite or something. So maybe in this one we should have a problem when x is equal to minus 1 in this picture. So this should have some sort of problem when x equals minus 1, which is 3 of the pictures. So we're onto a good thing there. I think probably I'm going to eliminate b and d because I want my graph to have a problem when x is minus 1. And maybe I could think about what's going on when x is very, very large. If x is huge, this thing is very negative. That happens for this one. X is very negative, but there's also a minus sign up the front, so it's very confusing. Chat has got 96% correct answers. I love this. The right answer is C. This is a pair of reflections. Flip it and then flip it, and you end up with a picture that looks like C for that combination of transformations, which is the same thing as a rotation by 180 degrees. Here's another example of that happening. Homework, which is not really how live streams work as discussed, and homework for just trying out other stuff. Let's have a quick look at chat. Chat's at 94% on that one. Brilliant stuff. Well done, chat. 4 marks in the bag. Which brilliant, good. Okay, it's just the sort of clickbait that we put, and then we also save it forever. I'm going to read the FOI chat. I think it's something about data and shortlisting in computer science, which is not something I do. Yeah, I'm not disappointed. Not something I'd expect you. Yeah, I would expect. I think it's okay for me to tell you a fact and then be like, that fact I told you less than 30 seconds ago. What's that? Right, homework. I think you can probably have a guess. Play around with Desmos or something. Can you guess what this function is? Behind the scenes, to write this question, somebody has actually come up with the function f of x and plotted it and put the plots onto the test paper. I think you can kind of invent it yourself. You know what 1 of x looks like, right? You know that 1 of x looks like this. 1 over x. 1 of x. Just 1 of x. How many have we got? Oh, just 1. 1 of x. 1 over x. And probably we can do some transformations and maybe add some functions together to get it to look a bit more like this. I reckon we might need to subtract x off there as well. But not quite that, because it's the other way up. So maybe like that or something. But maybe some numbers. And maybe not quite that, but maybe something a bit like that. Something over x minus 1, yeah, dividing by x minus 1 is a pretty good idea. I agree, because that famously has a problem at minus 1. So maybe I want this. That's my first guess. I'm going to try and put that in Desmos now. We did a little bit of live Desmos. We've got time left over. That never happens. Doing the long question first. Brilliant stuff. Let's try and work out what it is. So I think minus sign, I want a 1 minus x down here. Do I want 1 minus x or x minus 1? Sorry, I should read chat. Precious says x minus 1. That minus sign, and I think maybe subtract x as well. That's not too bad. Is that like the one in the question? Oh no, the one in the question goes through the origin. How can I make this go through the origin? Currently goes through 1. I'm going to subtract 1 from mine. That looking good? That's looking pretty good. I think that might be it. We might have got it. I might have done your homework. Yeah, I think I may have done your homework. Right, cool. Homework's over. Leave. 1 of x, the function that takes x and returns 1. Let's define that function really quickly. So my function f of x is going to be called 1 of x, and that's the indicator function. Let's not do the indicator function now. Let's just write the phrase indicator function on the board. Leave it at that. It's got its own weird notation. Good. How is MAT score used? Asks Bruce, which I think lines up with this question, this repeated question in chat about FYI requests and computer sciences process. So we use the MAT score. We compare MAT scores together. In the maths process works like this. I look at the MAT scores and I make broad recommendations for across all the colleges, considering all the maths applicants together. What's a good MAT score this year? What's an okay MAT score? And what's a not very good MAT score? And I use that to make really broad recommendations, and then tutors go and look at the actual details, and they make nuanced decisions within those bands. So it's not hard cut off because we've got actual humans looking at the applications through there. But you do get, as a result of your MAT score, you get kind of broad recommendation from me. That's for maths applicants. For computer science applicants, I think they're doing something different. Let's do this because I think it's important for the tone of the stream going forwards and now. I don't think I know. I've avoided finding out. So the question at the top here is, OMG, James, what's your opinion on Andrew Tate? I know a tiny bit about Andrew Tate, and the tiny bit that I know about Andrew Tate has caused me to not want to find out more about Andrew Tate. Sounds like a terrible, terrible, terrible person. And as soon as I found out enough to think, that sounds like a terrible person, I decided not to find out more about Andrew Tate. I understand Andrew Tate has been banned from this platform, so I'm still here and you're not. Good, right. Chat is... I don't particularly love the phrase safe space. Chat's just quite nice. We're nice around here, chat. Have I got an extensive list of swear words that are not allowed? What a follow-up. What a follow-up. No. Right, good. How do I know to minus x? Oh, I don't know, subtract minus x. I've seen things a little bit like this before. I can see that instead of tending to a constant, it's tending towards something sort of sloped. At some point in, oh gosh, when did I learn about oblique asymptotes? Okay, this is not math advice, but this person here, you're anonymous, so I don't know who you are. I'm pointing at the camera, which was a little bit aggressive, sorry. This is a nice place. You might like to look up the phrase oblique asymptote. Partly because it's such a good pair of words. It's got all these Q's and Y's. Oh, lovely. Oblique asymptote, which means an asymptote that's at an angle. It's something that happens where you get a function like this, 1 over x minus x. When x is really large, it gets close to a straight line. So I can see that this function is kind of straightening out to a straight line. Here it looks like it might even be the same straight line for large x and for very negative x. It doesn't have to be. But you can have functions that get close to, instead of getting close to a value, they get close to a line. Later on in your life, you learn about functions that get close to other functions as x gets large, whatever that means. Right, okay. Did not talk about indicator functions, but there is now a link in chat to the Wikipedia page if you want to learn about those. How do I word my answer? Yeah, I get asked this quite a lot. I'm not sure I'm very good at wording my answer on tests. Not particular skill because I'm sort of rushing by default. So generally exam techniques, don't be like me. Try to take time to write more words. It is always good giving things names. Even if they're not the things in the question, coming up with your own names for variables is pretty good. Okay. on multiple choice. Obviously, if it's obvious you got the right answer, but you circled the wrong choice. So there's a grid, by the way. Let's have a quick look at the grid. I can show you the grid where you put your answers in. So question 1's marked. It's multiple choice. You put your answers into this sort of grid. Let's just grab. Okay, so this is the 21 test, but we're not going to look at the questions. There's this grid where you tick boxes. So there's the instruction for question 1 is tick boxes to show your answers. If you tick the wrong box, not the one that you meant, then you're almost certainly not going to get the mark. Sorry. Please tick the box that you mean and check carefully that you've ticked the box that you meant, because we've created this box to make it faster to mark by just looking at ticking the boxes. Tutors have access to the scripts, so they can come back and look at your scripts to find out what you were doing, but by default, if you tick the wrong box, you don't get marks. Sorry. What's the lowest math score that you categorically cannot get into Oxford with? The limit does not exist. I think we've admitted people with no math score. Carl says don't give him attention, and I think I know who they're talking about, but it's more funny to imagine it's me. Don't give James. Don't ask him for general advice, exam tips. Okay, I could do a hot take exam tip. Come on, you've asked. I saw you ask twice. I'll give you a hot take. Some people will tell you to read all of the questions before you answer any of them. I'm the opposite. I can't resist doing bits of questions when I read them, and I don't try to stop myself. So I look at the questions, but I start doing them while I'm reading them by scribbling on the question or by just putting them in my brain, so that by the time I've looked at the questions, I've done a couple of easy bits of question on my way past. I've got a sense of how the next hour or two of my life is going to go. And also the back of my brain is now doing all of the questions. Not very well, but it's maybe going to have an idea about something. So sure, I look at the questions, but often I get distracted and do some of the questions. I'm not sure if this is great advice. Getting distracted by things is not one of my character strengths. But maybe it's my hot take that instead of sitting there reading the questions, you're allowed to start doing them at the same time. Scribbling stuff down as you go. Bye, Tyrone. I think you actually left more than 5-10 minutes ago because I'm getting quite behind with chat. Good. Okay. Do I think, hello, what is this? Contribution of the reciprocal to line diminishes away from 0. Yeah, so I think it looks more like a straight line further away. It looks like some graphs that I've done. That thing we threw into Desmos really quickly. I mean, it looks all right, but I'm having good. You are allowed to say Cambridge, assuming that the star stands for an A. You are allowed to say that is allowed. Right. Cool. Personal life questions. I do. Everyone my age played Minecraft a lot. I think that's true. I'm still going. I'm not very good. Is this true? Yeah, okay, let's do the stat. I've been playing Minecraft for 10 years and I've never beaten the game. I'm just not interested. I've been playing for longer than there was an end to the game, and I'm just not interested in joining in with the content of the end game. I'm just building stuff, usually massive fractal stuff. I'm just building my massive fractals, and that's what I'm doing. Have you seen this year's math paper? This is a lovely question. Have you seen this year's math paper, James? I have written this year's math paper. Will I see it? Yes, I wrote it. I wrote some of it, and also working out. I didn't write every question, but I'm involved. There's a panel of local teachers and other people from the maths department who work together to pick which questions we're using and to oversee all of them and make suggestions and changes. Hot take: only answer the prime Gauss. That's a terrible tip, because they won't do question 1, which were 40 marks overall. Is it better to do short questions first or long questions first? Completely up to you. There are no rules. There are other tests out there. I was amazed to find out other tests out there where you have to do some of the questions first, and then the clock hits some time and you have to switch over to the other section. That's not like that. You can do what you like. You can come back to them. I think a normal thing to do would be to spend about half an hour looking at short questions, and then get bored and look at long questions, and then come back to the short questions towards the end. Okay. The star did stand for an A, so that's okay then. Cool. Right, we are playing fast and loose, really close to. Never mind. No, that's not. We are not doing the Minecraft stream. Right, cool. If we do the Minecraft stream, it's going to be fractals. I'm going to have to boot up some old worlds. But the problem with building fractals is that the problem with building fractals in Minecraft is that it's really easy, if you know about like cheats for Minecraft, it's really easy to just import things with tools. The handcrafted fractals where you go around and you build stuff very, very slowly and badly. That's the real joy. Building. It's been a very long time since I went back to that. Anyway, right, good. Do I like Polya's book? So Cartan here. Come on, chat. Cartan here is referring to Polya's book, How to Solve It. I'm going to admit that I haven't read the entire book. I've read parts of that book. The parts that I read I thought were quite good, quite general advice, and some specific advice as well, of course. I thought the book was quite good. I think it's quite hard to find. If you can grab a copy of the book cheaply or from a library or something, then have a look at it. It's really influential, which means two things. It means it's a good book. It's got lots of problem-solving advice in there. But because it's so influential, it's influenced a lot of the other people out there who are giving you advice, like me. Even though I haven't read the whole book, it's still influenced me. So some of the advice in that book you're probably getting from other people as well, because in some sense lots of us are just repeating back things that other people have told us. Like loads of the advice I'm giving you is just advice that people gave to me. Do I care about GCSEs? Looking at the GCSE data that's just come out, it looked a little bit more like normal. GCSEs for this year's applicants is again a weird year of GCSEs. I think the data is probably a bit messy. I need to look at some data facts. Good, right, okay. Thoughts on Minecraft being Turing complete? Loads of things are Turing complete. Fractals are infinite, and that is the joy of building. You have a project that you can never finish. You just keep building stuff. Warwick and Imperial get some input, and they contribute a bit. They often give us really good feedback on changing questions in ways that I hadn't thought of. Do I suspect that P equals MP? No. Here comes the question on chat. This is now a chat stream where we just chat about things. Do you suspect that P equals MP? No. I suspect that it's undecidable. My shock would be, I'd be astonished if P equals MP. I'd be a bit surprised if it turns out that we can prove that P is not the same thing as MP. But my intuition from mathematicians I've talked to is that it's probably undecidable, which means that we won't be able to prove it either way, or it's sort of independent. I think that's what it means. I got a hot take from a different mathematician that it's probably undecidable. But that mathematicians I've talked to also think that collatz is probably my hot take for collatz. People asked about collatz a few weeks ago. We didn't talk about collatz. Collatz, there's some evidence that seems very convincing to me that collatz is probably also undecidable, which is a bit problematic, but hey. Do I expect we can prove it's undecidable? Personally, I can't. So it's not really unprovable, it's just the answer is not quite what people are expecting. Could undecidable problems be decided with different axioms? I think the answer to that is yes. You can make one of your axioms be undecidable problem is true rather than, or you could choose undecidable problem is false. I think that if you count that as an axiom, then I think that resolves stuff. This is not my sort of maths. Can you tell? This is not. Yeah. So Rabble's correct. If P equals MP, then n is 1, or P equals 0. Don't forget, you're dividing by something that could be 0. That is an algebra joke. Do I think infinity is actually -1/12? No. Terry Tao's got a really good hot take on that. Not hot take, but because it's Terry Tao, so it's just a kind person will find it in chat, or I'll look it up afterwards after we're live. Terry Tao's got a brilliant article about the whole -1/12 thing. There was an extremely popular YouTube video, a few years ago about -1/12 that got a bit of flack, and then it got a bit of backlash. And then it got some response videos, and then Terry Tao wrote a really well considered, very difficult blog post that explained things I thought quite well. Good, right, bye. Okay. Niccolo Fontana Tartaglia. Oh, it's Tartaglia. Sorry. Is that Tartaglia's name? There's some research going into chat at the moment. Here we go, Tartaglia. Oh, goodness me, there's also a video game called Tartaglia, guys. No, okay, this is not. Yeah, no. Is this Tartaglia? It's Nicola. That's Tartaglia's name. Oh, brilliant! I'm learning with chat. Sorry, your school teaches further maths in year 13 after teaching maths in year 12. So you're going to be learning further maths. You're probably learning complex numbers when you go back to school in a month or two. So you can look forward to learning about complex numbers and knowing just why everyone in chat is so excited about them. Will further maths topics be expected with knowledge at the interview? Maybe a little bit. The good thing about interview is that you can ask for clarification because we're actually there, and if it's clear you haven't learnt about something, we can change the question or ask you something different, or we can teach you a little bit of maths really quickly. Learning maths quickly is something that you're probably quite good at. Good. What would I do? You try and solve Navier-Stokes. Hey, I did solve Navier-Stokes. That was my PhD. In one very, very particular case. Tartaglia. Oh, complicated stuff. Very good choice of chat name. Maximum respect over there. It's about 7 PM. We're gonna wrap up very soon. If I missed anything really important, Wang just says zeta function in chat, which is not on the map. Is there a live stream on interviews? Yeah. So there's a bonus live stream. Let's have a look at the live stream schedule. Let's have a look at the live stream schedule because I can't remember what I've actually put on the website. Am I logged in? No. Good. Right. Okay. Here's the live stream schedule for this year. I can't believe we finished early. We never finish early. And then overran anyway. Here I am overrunning. So schedule coming up next week. Oh, next week logarithms. Next week logarithms. I'm so excited. We're going to learn about logarithms. And then we've got integration, differentiation, algebraic polynomials. Later on, primes, proof and recursion. This is the computer science special. Later on, we've got bonus live streams on things that are not the maths later on. So expect an hour or two of just chatting about complex numbers or all the stuff, sort of 100% tangents for 3rd of November. 17th of November, we're going to talk about the math paper. And then 1st of December, we're going to come back and do some interview advice for anybody who wants to know about that. That's going on there. And I am going to go and have some sort of curry. Let's wrap this up. Pigeonhole principle, good idea. Write that down. Nothing in personal statements make me cringe, except my own. My own personal statement is very cringe, and when I read it now, I think it was cringe. Yes, okay. There are things that people write in their personal statements that make me cringe. For example, maths is at the centre of everything in my life. That's the first sentence of my personal statement. If you want to see the rest of it, you can find it on this YouTube channel. Ridiculously, I did my PhD on mathematics, which is. I did a problem in fluid dynamics. I think you can get it on the internet. You will find out. It's out there somewhere, but it's not very interesting to look at. Good, right, okay. Tips on question 5. Combinatorics, recursion. The recursion live stream is going to be really good. Often just relies on explaining why something's true. Do some more words. Good, right, okay. Bye, thank you. What are my hobbies? Yeah, what do I do? What do I do? Oh, is that a link to my personal statement? Or is it a Rickroll? Let's find out. It's a new link for a Rickroll that I've never seen before. Yes, it is my personal statement. There we go. There's a link in chat for my personal statement. Goodness me, that video's got 10,000 views. That is too many. Okay, so if you think your personal statement is embarrassing and you're not enjoying writing it, it could be worse. There could be 10,000 people looking over your shoulder at what you've written. And my goodness. Yep, good, okay. Bye everyone, take care, I'm gonna go. Doing the long question first. I agree with Rebecca. Doing the long question first is, I think it was maybe a better use of everyone's time before you all had to go. Okay, right, cool. How do I switch this off? I switch this off like this. Bye, see you next week for, yes, logarithms, can't wait.